Okay, this video documents the RFI that Mike, W9RE, is receiving on 160 meters. Got my SDR receiver hooked up to his end-fire broadside array. In this video, we're pointing to the southwest, but he had very similar signal strength to the west and northwest, just a dB or two difference in those other two directions, which was kind of interesting. We also had another signal source here that was pulsing. We believe was also power line interference, but that was from the northeast direction. We're going to ignore that. So this is the RF spectrum. This is the modulated audio spectrum. We've got heavy content at 120, 180, 240, 300, etc. hertz. On the right-hand side of the screen is my audio oscilloscope that's receiving its signal directly from the SDR receiver. And you'll see I've got the cursor set at a spacing that represents 60 hertz. And we've got an arc here. We'll say that's at 1/2 of the AC sine wave. This next arc is at a rate or a spacing that would represent 120 hertz. That would be the other half of the sine wave. And then back to the first half of that sine wave, we've got the other arc. And I'll turn up the audio so you can hear what it sounds like. Okay, in this video, we are using the SDR receiver hooked up to just a small 12-inch diameter untuned shielded loop. We're sitting about 250 feet from the suspect arcing pole. And you'll see in the demodulated audio spectrum, we had a lot of heavy content at 120, 180, 240, 300, etc. hertz. And on the right-hand side of the laptop display is my audio oscilloscope that's receiving its audio from the SDR receiver and pretty much processing it real time. I've got the cursor set here on the peaks, this first peak and the third peak, and you'll see that the frequency is just a hair over 60 hertz. And so we're getting a arc in 1/2 of the sine wave. The other half of the sine wave, we get another arc, and then back to the same half of the sine wave as the first arc, we get another arc. And so that's how we wind up with a rate of 120 hertz. This video was taken when I was using a 4-element Yagi tuned for about 439 megahertz. I was connected to my SDR receiver, and this is the SDR receiver over here. This is a 10-second clip that I saved, and I've got it frozen right now. This is the RF spectrum. This is demodulated AM audio spectrum, and you'll see heavy content at 120, 180, 240, 300, etc. hertz. And then on the right-hand side, at the same time I was running the audio oscilloscope that was receiving its signal from the SDR receiver. And you'll see we were getting 120 hertz arcing. The cursors, red cursors, are spaced apart, showing that this first arc or spike and a third one was at a rate of 60, just a hair over 60 hertz. And the middle spike would have been the opposite half of the sine wave arcing. So that's how we wound up with 120 hertz arcing, arcing each half of the sine wave. I use my 4-element VHF Yagi to track the problem down to this grouping of poles. I then use my 4-element UHF Yagi to isolate the problem to this 2-pole structure. After I isolated the RFI down to the 2-pole wooden structure, Mike and I contacted AES, where we have some direct contacts with the radio group that is responsible for tracking down RFI. They went out there with their radar engineers, model 243, and radar engineers parabolic dish, and confirmed that the RFI was indeed coming from this pole, and they put in a work order to have this pole overhauled.